Hello again. Let's continue on our looking at putting things in order as far as cross sections go, and let's just look at folds and faults and do a little defining of those so we're a little bit clearer on what those are. Alright, so when we're dealing folds and faults, we're looking at rocks being under stress. So we're either compressing, pulling apart, some way that we're going to deform the rock. So the three different stresses that we're looking at: something that's pushing them together, which is a compressive force; something that's tearing them apart, which is a tensional force, a stress; and then there's a shear stress where they're sliding past each other. So think of this in terms of plate tectonics as convergent, divergent, and transform type boundaries. This happens at a rock level, can happen as we're moving these things together, apart, and a number of different things can happen. So that is the stress that's being applied, that's the force that's being applied, and then we have the strain, which is the response. So this is how the rock responds to this type of stress. There are three different ways the rock can respond. It will either have an elastic response, where it's going to return back to its original shape. It's going to have a plastic response, where it's going to be molded or bent. It doesn't necessarily return to its original shape. And then there's a fracture strain, which is going to cause the rock to crack or to break. All of these can happen with pretty much any kind of rock. It depends on the force that's applied and the resistance of the rock. So in that case, we're looking at a plastic strain when we're looking at folding, and we're looking at a fracture strain when the rock is breaking. All right. So again, three different things that we can do: no change, some recovery, no recovery, or we break, right? The rock breaks. And again, that's going to depend on the nature of the rock, how hot the rock is, the speed and the stress of that force that's being applied, and how much pressure it's under. So that's what the confining pressure is. And this is going to be different with the different kinds of rocks depending on their formation and all of these different types of variables that we're looking at as well. So a lot of things can be in play here, but let's look at the simple stuff and look at how we can understand this. So here we have any given rock where it's going to have a recovery, then it's going to start to deform, and then it's going to start to break. All right, so let's go back to our sedimentary rocks. So it's just, again, what we're going to primarily be dealing with out in the field. Nice, and going back to those principles of geology, layers are usually horizontal. When they are folded, these are bends in the layered rock, and this is a plastic strain. So usually this is a horizontal stress. It's going to produce domes and basins, and the main structures for folding rocks are going to be anticlines, which are in these arch-shaped, and a syncline, which is trough-shaped. So let's see what those look like. So here we have our different stresses. There is your syncline, and over here is your anticline. And you can see where this fold is happening, kind of an apex of this fold. So a lot more stress here, and a little bit lighter stress here. So here's your anticline, nice little artistic representation, pushed together, and we have older strata on the bottom, younger strata on the top. So old rocks here, young rocks here, and then again we have our syncline, older and younger. The cool thing about these is if you're walking across, you're going to go from old to young. If this has been eroded away up top, we're going to go from young to old. So we would go from old to young, young to old, anticline, syncline. You can start to infer from there based on what we see with the rocks. All right, now let's move on to faults. So this is going to be relative movement, opposite sides. You have a hanging wall and you have a footwall. The footwall is below the fault, the hanging wall is above the fault, and we have that fault plane, and that's between the hanging wall and the footwall. So we have different kinds here. This is a mining term. So here's our hanging wall here, here's our footwall here, and we can look at a strike and a direction of dip to see what's going on with that. All right, so the hanging wall is either going to move up or down in regards to the footwall, where the person is standing from. So in this case, you can see if this is our footwall and this is our hanging wall, you can see how this is nice and color coordinated. So things dropped in this case. And we'll talk about what kind of fault that is here in just a minute. All right, so we have different classes of faults. We have a normal fault. So the hanging wall in this case has moved down relative to the foot wall, and we're looking at different types of features. We're looking at horsts and grabens. So the block is surrounded by normal faults, and that is going to drop down, and the horst is a block surrounded by normal faults, and it's uplifted. So let's look at examples of that. So in this case, this is a tensional force pulling them apart. There we have that hanging wall dropping down. There's your footwall, so there's a normal fault. Here is your graben, so again, tensional force here, and that is going to cause this middle part to drop down. So there's your graben, and there is your horst. So these sides are dropping down relative here. So there's your horst, there's your graben. And then, of course, another fault that we have is a reverse fault. In this case, the hanging wall is moving up relative to the footwall, and this is a compressive stress, so it's coming towards it. And then we have another kind of reverse fault, which is a thrust fault, and this is a low angle reverse fault, and it's going to give you an idea of what kind of forces we're dealing with. So here we go, we're pushing together, this is moving up, this is moving down. And then we have that low angle, so this is less than 30 degrees, but we're still causing this side to move up, and this side is relatively static. So hanging wall here, and there's our footwall on each one of these examples. Here's an example of horsts and grabens. Again, there are also different types. With those, we're looking at a horizontal offset with these as well, so that horizontal stress is going to be caused with earthquakes. By the way, this is a picture of a section in Colorado called the San Luis Valley that has multiple horsts and grabens, so lots of different normal faults going on here. All right, go through here, and this is another kind of fault that we're looking at, a transform fault. See how these things are pushing past each other, and this is an actual field. And you can see the offset here. Now, depending on where you're standing, if I'm standing here, then everything has moved to my left. And if I'm standing here and facing the screen, again, everything has moved to my left. So depending on our angle, no matter which side we're on, based on where we're at relative to us, things have either moved right or left in these transform faults. All right, so we're going to go and those different kinds of faults. Your review here, we have a normal fault, we have a reverse fault, another type of reverse fault, a thrust fault, and we also have a transform fault, which gives us our right or left lateral movement. And then we also have horsts and grabens for normal faults. And we also then look at our folding events, which are anticlines and synclines. And with anticlines, we move from old to young, and then from synclines, we go from young to old. So that is it for our folds and our faults.